I'm about I'm about three steps to the right of pissed off thoroughly at the book. All right, on page 99 of your book, page 99. All right, on page 99, they've got a mistake. Made me look like an ass. That's why I didn't. I had 10 minutes of a great lesson on this problem worked out, and I lost my nerve. And I said, well, I better check this out. So I checked and I double checked and I checked and I double checked, and I had the son of a gun right. And they the answer is 1.6 meters, not 16 meters. I mean, it just and I looked, they have a mistake. They forgot they forgot the decimal point. But anyway, so here we go. Kid on a sled. All right, kid's riding a sled. Whee! All right, so the kid's riding a sled, 4 meters per second going this way. There's a coefficient of kinetic friction of 0.5. So he's going to come to a stop. So his V naught is 4.0 meters per second. V final, 0. Okay? All right, so we know that there's going to be an acceleration. There's got to be a negative acceleration of some sort that's going to bring him to a stop. We want to find that acceleration. We want to find the distance that he traveled to come to a stop. And we want to find the time. Those are the things that we want to find. We've got to use our idea of forces, and then we use our kinematic equations, and we solve this. And it's a piece of cake. Watch. I had it perfect before, but they mess with me. All right, so now let's draw the free body diagram. You only draw forces. Kinetic force going this way. mg pulling down this way. Normal force going this way. Sum of the forces in the y direction are equal to 0 because he is equal to, so the MA is equal to, so I've got Fn minus mg. So therefore, mg is equal to Fn. I'm going to be very meticulous about that. You're going to have to, I'm going to work, because sometimes, like if we're at an angle or something like that, the normal force will be less than mg. If I decide to put, if a friend jumped on the back of this kid on the sled, the normal force would be greater than mg of the kid. All right? Of course, then we'd increase his mass, but that would increase the normal force. All right? But the main thing is think of the slant. All right? So, sum of the forces in the x direction. Let's do that. Oh, he's got an acceleration that's negative is equal to minus f of k. All right, let's figure out what that is. Now, they didn't give us a mass. I wonder why. Probably figured that out. So we've got m of a is equal to mu k minus mu of k times the normal force. Well, keep working. ma then equals minus mu of k times mg. Did that substitution. Oh, so the acceleration is minus mu of k times g because the masses cancel. Sweet. So the acceleration is negative 4.9 meters per second squared, slowing this thing down. All right, so we've got this one. Found that. Let's figure out the time. I like to do the time first, especially if I've got the two velocities. Makes it a piece of cake. So final velocity is equal to V naught minus AT. That's one of your kinematic equations. You're going to have that equation on your, so we got 0 is equal to 4 minus 4.9 times t. So 4.9t is equal to 4. So t equals 4 over 4.9, and that comes out to be 0.81 seconds. I know that for a fact because that's what I did before. So this equals 0.81 seconds up here. Now, let's find the distance. Well, you got the distance formula. The real distance for it is x final is equal to x naught plus v naught t minus 1/2 at squared. Now, Some of you, I've already factored out the negative 4.9 here and put it here. If I made this a plus sign, it would look like this. So don't double negative yourself. All right. So I've got x final is equal to 0 plus 4 times 0.816 minus 1/2 of 4.9 times 0.816 squared. And what I get when I do that is 1.638 meters, not the 16 meters that they say. And they solved it this way. They said v final squared equals v naught squared. I don't like this equation because it's not doing physics. It's just an algebraic trick. One, it takes away the vector direction of everything. Minus 2a times x final minus 0. And so I've got 0 is equal to 16. This is where I screwed up before. I squared that again. So I've got 4 squared, which is 16, minus 2 times 4.9 times x final, because the x final is 0. So I've got 9.8 times x final, because I brought that equals 16. So x final equals 16 over 9.8, and we can definitely see that that's almost divided by 10, so it comes out to be 1.638 meters. Again, that probably was better because my last one I took 10 minutes to do. That one took 5. We'll do one more.